Of the countless domains of knowledge that constitute the hacker's toolkit, perhaps none is more fundamentally critical than a deep and intuitive understanding of common network protocols, the standardized languages and rules that govern how devices communicate across networks, as these digital dialects not only form the backbone of all modern computing, but also represent the primary attack surface through which both offensive and defensive cybersecurity operations are conducted, creating a landscape where mastery of protocols like TCP, IP, UDP, DNS, HTTPS, ARP, and DHCP transforms a random attacker into a surgical operator capable of manipulating the very fabric of digital communication to achieve objectives ranging from stealthy reconnaissance and man-in-the-middle attacks to service disruption and data exfiltration. At the absolute foundation lies the TCP/IP suite, the conceptual model that defines internet communication through its layered architecture, with hackers paying particular attention to the Internet Protocol, IP, at the network layer, which handles logical addressing and routing through IPv4 and IPv6 packets. Understanding how to manipulate the time to live, TTL field, to map network paths with traceroute. How to craft packets with spoofed source IP addresses to obscure their origin or launch distributed denial of service attacks, and how to analyze IP header information to fingerprint operating systems based on their default TTL values and packet fragmentation behaviors. Operating at the transport layer, the Transmission Control Protocol, TCP, provides connection-oriented, reliable communication through its sophisticated system of flags, sequence numbers, and acknowledgements, with hackers exploiting its three-way handshake, SYN, ACK, to conduct SYN flooding attacks that exhaust server resources, using crafted packets with specific flag combinations like XMAS trees, FIN, ERG, PUSH, or null packets to probe firewall configurations and identify filtered ports, and hijacking established TCP sessions by predicting sequence numbers to take over authenticated connections, while its connectionless counterpart, the User Datagram Protocol, UDP, becomes a vector for amplification attacks in DDoS campaigns due to its stateless nature and the ability to spoof source addresses when interacting with services like DNS or NTP that generate larger responses than the initial query. The Address Resolution Protocol, ARP, operates at the crucial intersection between the network and data link layers, maintaining the mapping between IP addresses and MAC addresses on local networks, creating what is arguably one of the most fertile grounds for network-based attacks through ARP spoofing or poisoning, where an attacker sends forged ARP messages to associate their MAC address with the IP address of another host, typically the default gateway, thereby positioning themselves as a man in the middle to intercept, modify, or block traffic between unsuspecting victims and the network, a technique that forms the backbone of more sophisticated attacks against encrypted sessions, where even HTTPS can be compromised if the attacker can position themselves between the client and server during the initial connection. Similarly, the Dynamic Host Configuration Protocol, DHCP, which automatically assigns IP addresses to devices joining a network, presents multiple attack vectors, including DHCP starvation attacks that exhaust the available address pool to cause denial of service, rogue DHCP server deployment that allows attackers to assign themselves as the default gateway and DNS server for clients, thereby controlling their network traffic, and DHCP snooping to gather intelligence about devices on the network by monitoring lease requests and acknowledgements. For name resolution, the Domain Name System, DNS, serves as the Internet's phone book, translating human-readable domain names into IP addresses. But this critical infrastructure becomes a weapon in the hacker's arsenal through techniques like DNS cache poisoning, where corrupt DNS data is introduced into a resolver's cache, causing it to return an incorrect IP address and redirecting traffic to malicious servers. DNS tunneling, which encodes data from other protocols within DNS queries and responses to bypass network security controls and exfiltrate data from compromised networks. and DNS amplification attacks that use open resolvers to flood targets with massive amounts of traffic by sending small queries that generate large responses to spoofed IP addresses. At the application layer, the Hypertext Transfer Protocol, HTTP, and its encrypted counterpart, HTTPS, represent the primary interface between users and web services, with hackers developing an intimate knowledge of their request-response structures, headers, status codes, and methods to identify vulnerabilities. Understanding how to manipulate cookies for session hijacking, craft malicious post requests for SQL injection, alter HTTP headers for cross-site scripting, and exploit insecure direct object references by manipulating URLs to access unauthorized resources. Even with the encryption provided by HTTPS through TLS/SSL, hackers analyze the protocol handshake to identify supported cipher suites and potentially force downgrade attacks, exploit vulnerabilities in specific implementations like Heartbleed, or use certificate manipulation to conduct man-in-the-middle attacks when proper validation is not enforced. For email communication, the Simple Mail Transfer Protocol, SMTP, becomes a vector for phishing and spamming campaigns when open relays are discovered, allowing attackers to send massive volumes of malicious emails while obscuring their origin. While understanding SMTP commands enables email spoofing by forging headers to make messages appear to come from trusted sources. The File Transfer Protocol, FTP, and its more secure variants like SFTP and FTPS are frequently targeted for anonymous access misconfigurations that allow unauthorized file retrieval or upload, credential brute forcing due to often weak authentication, and traffic interception when encryption is not properly implemented. Beyond these common workhorses, hackers must understand specialized protocols for specific environments. Server Message Block, SMB, for Windows file sharing and printer services, which is exploited for lateral movement through pass-the-hash attacks. Null session enumeration to gather system information without authentication, and as the propagation mechanism for worms like Eternal Blue. Simple Network Management Protocol, SNMP, used for network device management, which when configured with weak default community strings like public, can reveal extensive network topology information, device configurations, and even allow remote configuration changes, and Telnet and SSH for remote administration, with Telnet's cleartext communication being a prime target for credential sniffing, while SSH keys become targets for theft to gain persistent access. The advent of IoT has introduced protocols like MQTT for machine-to-machine communication, which when implemented without proper authentication, can expose critical sensor data and control systems to manipulation. For voice communications, the Session Initiation Protocol, SIP, used in VoIP systems suffers from vulnerabilities, including registration hijacking, message tampering, and denial of service attacks that can disrupt business communications. The hacker's practical interaction with these protocols occurs through a sophisticated toolkit, Wireshark, for deep packet inspection and protocol analysis, allowing the dissection of communication down to individual field values. Nmap, for protocol-specific scanning techniques that can identify services, versions, and potential vulnerabilities based on protocol implementations. Metasploit modules that weaponize protocol vulnerabilities into working exploits. Scapy for the custom, crafting, and manipulation of packets at the protocol level to create novel attacks or test protocol implementations. And Burp Suite for manipulating application layer protocols, like HTTPS, during web application testing. What separates the skilled network hacker from the script kiddie is the ability to think not just in terms of tools, but in the language of the protocols themselves. Understanding how a TCP sequence number is generated and predicted, how a DNS query can be crafted to bypass filters, how an HTTP header can be manipulated to break application logic, or how an ARP table can be poisoned to redirect traffic. This deep protocol knowledge enables the creation of custom attacks, the development of sophisticated evasion techniques to bypass security controls, and the ability to diagnose complex network issues that stump less knowledgeable administrators. In the endless cat-and-mouse game of cybersecurity, the protocols that enable our connected world remain both the foundation of modern communication and the hunting ground for those who understand their secrets, making protocol literacy not just an academic exercise, but an essential survival skill in the digital landscape, where every packet tells a story and every protocol handshake represents either a secure connection or a potential breach waiting to happen.